So, hello guys, my name is Leonardo and now I'm gonna present here the paper entitled Formalization and Evaluation of EAP, aka Prime Protocol for 5G Network Access Security. So, this is the sections of my presentation, beginning with the introduction, some statistical data that I bring here regarding the paper. This is the full reference for it if you want to check it, and the number of citations in both Scholar, Google Scholar, and the Scopus databases were just one citation, and the journal itself, called Array by Elsevier, didn't score that much in the statistics regarding the journal itself, and for Brazilian CAPS Qualis measurement system, it scored only a B2 rank, so nothing impressive here, but still you see the importance of this work. So the general context of the work is that they provide an analysis of the EAP-AKA Prime protocol using the 5G implementation from the technical specification by 3GPP 33501, and this is the reference for it if you want to check. And they have a simulation environment using a 5G non-standalone architecture setup, because they mix some elements from 5G and 4G. This is why it's non-standalone architecture. And they use the NS3 network 3 simulation and the 5G millimeter wave module that is provided in the NS3 for their environment. And they used a 5G radio implementation that's not specified, but is a custom implementation, and a LTE core network. This is why we have NSA, so they used a core for LTE, not 5G. And they explored and compared both 5G AKA and the EAP AKA Prime authentication protocols, and they explore a little bit about the Radius protocol, which is another authentication protocol, which is used for authentication and accounting too. And they compare Radius with Diameter, which is the protocol for 4G, and they make some comments regarding them and some comparisons. And that's it. So the background is that we have our range like this. We have the user equipment, 5G enabled device. We have the base station or the new radio, the G Node B. And we have the core, which in this case is a 5G, but in the work case is a 4G one. And we have access for the UE to the internet. So some key concepts in this paper. The first one is the home network and the serving network. The idea is the home network is the place where the user is registered, and the serving network is the network where which is distributing the signal that the device is connected to actually. And they can be the same network, or they can be different networks. So the serving network can be operated by another operator, which means that roaming is possible. And that's it. So they compare AGN and SN this way. And the other thing is the IMSI, which is the International Mobile Subscriber Identity. Here we have an example of this number. So the first thing is the MCC, which is the mobile country code. The second part is the MNC, the mobile network code. And the last part is the MSIN, which is the mobile subscriber identification number, MSIN. So the idea is that we have these codes concatenated. So we have 3 digits for the country, 2 or 3 digits for the operator, network operator, and 10 digits for the identification number of the subscriber. And then we have a number, which is the MSE, with 15 or 16 digits of length. And this is a unique code like worldwide. You have only one MSI code for each device. And then we have the network access identifier, which is the NAI. And the idea is you have a username port and a realm port. So the realm port is optional because if you are authenticating in your own network, you don't have to provide the realm, as your username and password will be you suffice the idea of authentication. But if you are roaming, you need to provide the realm together with your username. Realm is just an address to point you to your home network. And as an example, we can use as username anything we want. This is an example of a CPF number, a fake CPF number, and realm is UFJF.br. It can be whatever you want, given that this is valid. And for the 5G, we have the MSI, and the realm part works like that if you are authenticating in a wireless environment. Okay, so the last thing is the EAP, Extensible Authentication Protocol. This is like an umbrella term for more than 40 authentication protocols, authentication algorithms. And the one that he was exploring more in the paper was the EAP-AKA prime. And the idea, according to the authors, is that using this protocol, the involved parties should be able to derivate and agree on an anchor key that is used to generate the session keys between the UE and GNB. Okay, now the methodology and results. The requirement for the UE in this paper are general. So the idea is that you have a USIN, universal SIN. The SIN card is the subscriber identity module. You have access to asymmetric encryption / HMAC capabilities in the device. So you can use like a hash-based message authentication code. And you have the possibility of generating a session counter. And you have access to the subscriber's permanent identifier, which is the SUPI. And you have access to the home network public key because you need to authenticate this network. And you have a key, which is the K key, which belongs to the UE. Then the network functions in the network infrastructure that are involved in this process are the security anchor function, the authentication server function, authentication credentials repository and processing function, and unified data management. As you can see in this image here, they are involved in this authentication. This graph here shows, they call it reference points, but they are, in the context of 5G, they are the interfaces, the SBIs, and the modules that are involved in the primary authentication. So there is a communication happening between the ARPF and the UDM. So the UDM can connect to the AUSF and so on. The SAAF and the SCMF are connected to the AMF, so they can be used to make the primary authentication of the UE. So this is how the communication goes, and this is the main functions of the core. This is the UE RAM, and there is the data network, which was the internet in the previous architecture I showed you. And there is the possibility in the release 17 that you have a authentication server in this module here, the NAA. The general overview of the setup is like that. You have the UE using a USIN, as I said, and they call it peer, and it is connected to the SAAF in the serving network. So you use this module as a pass-through authenticator, and there is a secure connection between this module and the core using these three functionalities here in the home network. So here we have the authentication server and the home database, which has the data of the user authenticating. And one thing to note is that this channel here is insecure. So this will serve for us in the coming slides as something important, an important detail. Okay, so they made a formal verification using this software called ProVerify, ProVerif, I think. So the ProVerif is an automatic cryptographic protocol verifier in the formal model, as the so-called Dolev-Yao model. And this protocol verifier is based on a representation of the protocol by Horn clauses. This is the text that I quoted from the official website of the software. So the authors used this to make automatic verification of the cryptographic protocols involved, which is, for instance, the EAP-AKA prime. So they modeled and run the protocols using the so-called PubSec channel, secure PubSec channel in the ProVerif, and they used the compromised channel. And when they used this, a vulnerability discovered happened because they could run a replay attack in the message 4 of the protocol. I'm not giving you too many details here because of the constraints of the presentation, but they could run a replay attack, and this implicated in us having the possibility of many event number 2 messages for a single event number 1 messages. The idea is this specification says that this is not possible, so they have like a violation of the specification, and the authentication possibly could happen. And the problem is that the authentication did not hold as assumed by the 5G standard because of that happening. They discovered some other vulnerabilities, and one of them is that if the key of the SEAF module was compromised, then all past sessions of this module were compromised. So this pointed to us that there is no PFS, which is the perfect forward secrecy applied in this context. And the idea is that in the future we will have this, how can I say, tackled or mitigated by the proposed EAP-AKA PFS algorithm, which is still as a draft, but it will update the RFCs 5448 and 9048, which are the RFCs for the EAP and the EAP-AKA prime, by the way, and it will bring the PFS to the EAP-AKA. And if the K key is compromised, which is the key of the user itself, of the UE, the UE impersonation attack can be run, and this can be accomplished by hacking the USIN or the network operator, the mobile network operator. So this is a point of attention. The authors have run some performance verifications too. So this is the table that shows the details of each part evaluated. So they evaluate the execution, authentication vector, and so on. This is during the generation of the keys, and they have the computational time displayed here. And then there is another table showing the sum of each of the operations for each of the protocols evaluated. They compared these protocols. This above, I guess, is the EAP-AKA prime, and the other one is not detailed. But anyway, they made the verification of this run, which is which resulted in these equations here. So the number of times of any operation is represented here. It's slightly different from the protocols, and the idea is that the EAP-AKA prime resulted in a little bit extra time of computation time. But anyway, it was pretty close for 5G AKA, and it has some added security measurements in place. So now to finalize here the analysis and discussions, the authors, they used a well-known simulator, which is the NS3, and they provide the simulation parameters, which is listed in the paper. They used a well-known and widely accepted cryptographic protocol verifier, which is the ProVerif. It is widely accepted in the community, cryptographic community, as I researched it. And they provide some statistics and some mathematical definitions and proofs, which is good. And they provide a lengthy background information regarding both protocols and the setup they did. And they made an extensive evaluation, because the results I showed here are just a small part, a glimpse of it. So this is why because they provide extensive evaluation. Points of attention is no access to the results, I mean in the raw data, because they provide a lot of diagrams and graphs, but the raw data is not available for you to check. And as points of how can I say, bad points in this work, because no paper is perfect. They didn't provide the simulation environment, which is strange because they use the NS3. One of the strong points of using a simulator is the easiness in which you can, the ease that you can share the simulation environment, but they didn't do it. And they don't provide access to the source code, the implementation. They did, because they have two important modules implemented in a custom manner, so they could have shared this, and they didn't do. So as conclusion, they say that the protocols were formally analyzed and verified, utilizing automated reasoning about the security properties and for security guarantees that resulted in vulnerabilities being discovered, as we discussed here, and they evaluate the performance and efficiency of both protocols. And all security presumptions and requirements have been identified through the interpretation and analysis of the 5G standard and the EAP-AKA prime, according to the authors. As future work, they only cite this. They want to apply this methodology on the verification of future protocol guarantees and effectiveness of these protocols. And that's it. These are my reference for you to check. I will share the slides for you. And that's it. Thank you for the attention, and I will finish my presentation now.